Analytical balances are designed for high precision in quantitative chemical analysis. Prior to weighing any samples, tare the device by pressing T. The balance should read 0.00 grams. Place the material of interest in the weigh boat. Place the sample on the clean balanced surface, close the door, and record the mass once the reading has stabilized. The analytical balance should give numerical readings to 4 decimal places. Record the readings in your notebook. Graduated cylinders are used to measure liquid volumes. In this case of a graduated cylinder, place the dry cylinder on a level surface and add the liquid of interest up to the mark. Reading the meniscus should be taken at eye level. Pipettes are used to accurately transfer a measurable amount of liquid from one container to another. Fit the pump over the pipette, place pipette in solution of interest, and draw liquid up little past the mark. Remove the pump and place your finger over the end at the top of the pipette and slowly release the solution until the desired measuring mark is obtained. Then place the sample of interest in the appropriate container. In the lab, you'll be using alcohol thermometers, which is used to measure the temperature in a variety of mediums. When recording the temperature sensor should not be in contact with any glassware, and reading should be taken to 1 decimal place. Again, reading the temperature marks should be taken at eye level. The Bunsen burner is used as an energy source that provides a single continuous flame. Looking at the device, the bottom knob of the Bunsen burner is used to control the amount of gas flow entering the burner. The top collar is used to control the amount of air. Connect the tube to the blue gas outlet and turn the handle 90 degrees toward you to start the gas. Place the igniter an inch or 2 away from the top of the burner and ignite. A blue flame is hotter than an orange flame. Adjust the height of the flame with the air control dial. Never leave the Bunsen burner flame unattended, and turn off the gas from the main source when you are not using the burner. The primary function of the hot plate is to heat a chemical substance in a uniform manner. In addition to heating samples, most of the hot plates in the lab have the ability to provide heat and force to magnetic stir bars. When applying heat to samples, gradually increase the heat and monitor the rise in temperature. When adding or removing test tubes from boiling hot water, use a test tube clamp. Once the flame from the Bunsen burner is established, to clean the wire, dip the wire in HCl and place the end of the wire in the blue part of the flame for a few seconds. Then dip the wire into the sample of interest and observe the color change. The wire must be cleaned with HCl between samples. In this lab, the following unit will be assembled to determine the water content of a hydrate compound. Initially set up the Bunsen burner and then obtain a ring stand. Place the iron ring onto the ring stand. Then place the clay triangle on the iron ring. Followed by the crucible with the lid slightly ajar. Use the tongs. At no point should you use your fingers to touch the crucible, as the oils on your fingers could affect the mass of the crucible. Activate the Bunsen burner and adjust the height of the crucible so that the tip of the inner blue flame cone is in contact with the bottom of the crucible. Once heating is complete, use tongs to place the crucible on the wire and allow to cool. Washing a burette. To clean the burette, close the stopcock knob in a horizontal position and place 5 to 8 milliliters of distilled water in the burette. Turn the burette horizontally and rotate so that the water is in contact with as much surface area inside the burette. Now open the stopcock vertically to drain out the water. After cleaning with distilled water, repeat the steps with 5 to 8 milliliters of titrant to remove any water molecules left behind. When performing the titration, use a ring stand and attach a burette clamp. Insert the burette. Fill the burette with the desired titrant and ensure there are no air bubbles. Place a funnel at the top of the burette to facilitate pouring of the titrant. Pour the titrant up to the 0 mark. In general, when reading markings on the burette, take the measurements at eye level and record to 2 decimal places. Titrations should be done using an Erlenmeyer flask as a receptor. You can also use a white background to recognize any important color changes in your titration. The spectrophotometer is used to measure the absorbance at particular wavelengths. The initial step is to turn the power on switch and let it warm for at least 20 minutes. Label your cuvettes. Set the wavelength on the spectrophotometer to the desired value. Fill the cuvette 3/4 full. Wipe the cuvette to remove any fingerprints. Place the blank cuvette, which contains only solvent, in the cuvette holder in the sample compartment and close the compartment lid. After obtaining a reading, remove the blank sample from the spectrophotometer. Seal the top of the cuvette with parafilm to preserve the blank cuvette for future use. Now prepare a second cuvette containing the sample of interest for analysis. Again, wipe the cuvette and place it in the spectrophotometer. Of note, when changing wavelengths, the machine should be re-zeroed with the blank. For this experiment, you will determine the volume in the ideal gas law equation. Obtain 2 ring stands, appropriate clamps, a syringe pump, tubing, boiling tube, and set up the apparatus accordingly. In the end, the syringe pump will be in a horizontal position and the boiling tube in a vertical position. Place 1 molar HCl into the boiling tube. Angle your boiling tube and initially place the weighed out magnesium ribbon in the boiling tube but not in contact with the HCl. Push your plunger all the way in and reseal the boiling tube with the rubber plunger. Align the boiling tube vertically for the magnesium to come in contact with the HCl for the reaction to begin. Record the change in volume of the syringe pump.